Welcome everybody to today's installment of Math Videos. How depressing that you're watching it, but hey, it's better than me talking all the time in class, right? Right. Okay, today we're looking at something called systems of linear equations. Linear equations we are familiar with. A system of linear equations is simply more than one. So rather than looking at one equation at a time, we're going to be looking at multiple equations. Typically, that means two for us. But you could solve a system of three or more linear equations. The principles are the same as solving two, so we're going to start with that. But as the graphic shows, a system of linear equations will have one solution, and that one solution is where those two lines cross. That's the basics of it right there. If you can find the point of intersection, then that is the solution to a system of linear equations. Pretty straightforward. Let me give you some examples of what I'm talking about. Okay, so let's say we have these two equations, and we want to find the solution, and that is a point that solves both equations. Trying to solve a system of two equations is very difficult if you try to do it by trial and error, but it's quite a bit easier if all you do is simply graph it, and that's how we're going to be focusing on doing it in this section, is just graphing it. So I'm going to put these in slope-intercept formula, so they're very easy to graph. If you haven't figured out how to graph them, let me show you really quickly here. And I would say at this point, if you think you can graph this and find the solution on your own, you can go ahead and skip ahead a little bit to the next example. But if you're not sure how to graph these, I always start with a point if you have one. And in this case here, we have the y-intercept for both of them. So I'll do in black the top one there. Here's y equals 3 right there. And then the slope is 1/2. That means the rise is 1 and the run is 2. So 1 over 2, up 1 over 2. I'm just going to do that a whole bunch of times. Up 1 over 2, up 1 over 2, and just keep doing that. And you eventually get sorry, my video is not working properly here. Anyways, you eventually get the graph there for y equals 1/2 x plus 3. So if you have graph paper, do the same thing. You start with the point, -6, the y-intercept, and apply the slope. And so I'll start you off here. You're going to start way down here at 6, so 2, 4, right there. And then just go up 2 over 1, because this is like saying 2 over 1 times x. Up 2 over 1. Up 2, whoops, up 2 over 1. Just like that. Keep going until you intersect the other line. And so we can see that there is one solution that stands out, and that is this one right there. And that point should solve both equations. So the point is 6, 6, which means I can plug in 6 for x, 6 for y in both equations, and I should get a true statement. Well, let's look at that. So let's plug in 6, 6 for x and y into the equation on the left, and let's simplify it. And I get a true statement. Therefore, that solution works for that equation. Let's check the other one. And absolutely, that one works as well. So then when we're solving a system of equation, all we're doing is we're finding a point of intersection of two linear graphs. And so all those equations of straight lines we just finished dealing with, we can apply that to this chapter to graph lines and find their point of intersection. Alright, well, we're going to be seeing a lot of equations written in this form, in that it's like a modified general form. But you shouldn't be scared of it, because it actually makes your life a little bit easier to graph them when they're already like this. In other words, the constant terms move to the other side. And the reason why it makes it easier is because when you want to find the intercepts, all you have to do is cross out one of the other variables. In other words, if I want to graph these lines, I need 2 points, right? And so if I can just graph 2 points is all I need. So what I'm going to do is I'm going to find the x and the y intercepts here. So to find the x-intercept, I'm going to set y equal to 0. In other words, 2x equals 2, or x equals 1. That is the x-intercept. And then to find the y-intercept, I'm going to get rid of the x term. So y equals 2. Well, that's easy. And so 0, 2 is my y-intercept. So just by looking at it in that form, I get 2 points very easily. I don't even need to calculate slope to graph it. Let's look. I'll let you pause the video and find the x and y intercept for the right-hand side. Okay, so in the same order then, we'll do the x-intercept first, where y equals 0. Look at that. Whoops, it equals 7. And so that means that my x-intercept is 7, 0. And then if you do the same thing for x, you get negative y equals 7, or y equals negative 7. So that's 0, negative 7 is the y-intercept for that line. Okay, so I have those 2 points. Now I can graph that system of equations. If you want to go ahead and graph it and see if you can solve it on your own, go right ahead. Otherwise, let's see the solution here. All right, well, let's plot the points on the left first. There they are there. You only need 2 points to make a straight line. And so without actually calculating the slope, I can see it very easily. In other words, it's going down 2 over 1. So if I kept going down 2 over 1, that would give me my line. I can just keep going like that. And there's my, I can go backwards the other way as well. And I can sort of see where my line is going. All right, now let's look at the line on the right, the red line. There are my 2 x-intercepts, and I'm just going to join them with a straight line because I know where they're going to go. And look at that, one point stands out, and that's this point right here. And that point is the solution. Okay, I just had a bit of a glitch in my video. I'm not sure if you heard what I just finished saying, so I'll say it again. One point connects or intersects both lines, and that should be the solution to our system. So let's double check and confirm by substituting. Okay, so the point is 3, negative 4. I'm going to plug both those points into my original equations. And whenever you're substituting into an equation, I strongly recommend that you always use brackets so you sort of isolate it from any operations going on. So on the left here then, if I solve this, I get 6, and then plus negative 4 is the same as minus 4, and then that means 2 equals 2. Check, it works. On the right hand side, I get, okay, well, brackets, 3 in brackets is just 3. And then 3 minus negative 4 is the same as 3 plus 4. Whoops. 4, there you go. And then I get 7 equals 7, which is also a true statement. So that works, absolutely. Okay, so there you go. Just proof again that this system we're using has been solved and is working. All right, well, another example we could look at here is if I gave you the system and then asked, does this point, 1, negative 1, solve the system? And all I'm asking you to do there is to plug in that point into both equations and see if you get 2 true statements. If you only get 1 true statement, then it doesn't solve it. So if you plug the points in, you see you get really, really close to a true solution. What that means then is that the line or that point does not solve the equation, but it looks like it's really close. And why don't we take a moment just to graph that, and we'll sort of see how close that point is to solving both of them. All right, so there we have both graphs on the same plane there, and it looks like that point does solve it, but we solved it already and saw that it didn't, but it looked really close. And if you look really closely, you can see that that second line, which is this one here, okay, does not quite go through the point 1, negative 1. It's really close to it, but doesn't quite go through it, so it doesn't solve the system. Short answer. All right, well, this is the one I want you to solve for homework. I'm going to be checking it on Monday or next class. The solution, sorry, the solution to this one sucks. I'm not going to make you do it for homework because it is a really complicated answer. It's nowhere near being a whole number. Just give me 1 second here. There you go. The solution to this system is actually a whole number or integers, so you don't need to worry about anything crazy there. Okay, bring that, and on next class we'll talk about it then.